Oh, well, thank you, Kevin, and thank you folks for joining us today. My name is Ken Rost, and I'm the President and CEO of Frost Incorporated. We are a sprayer manufacturing company, but we also focus on uh, uh, precision agriculture technologies. We try to bring that to our customers as much as possible for obvious return on investment and just benefits for all. So um, I guess I'll just go ahead and start sharing my screen. And I enjoy working with Winfield. Winfield is a great partner to have in agriculture and turf care. So we've very much enjoyed a long-term relationship with Winfield. So thank you much for inviting me. Well, we are going to talk about sprayer topics and technologies for high value crops. Now, uh, I say high value crops. I think that anyone that puts in a crop isn't going to put it in if there isn't some value. But we know that there are some crops, especially the ones that we're dealing with here, ornamentals, tree and hops and cannabis, that have a pretty high value in relative to the acreage or the space that they're grown on. So that's what I mean by high value crops. And hopefully we'll learn some things here together. I am assuming that not everyone has the same experience level in this group. Um, you might be a traditional row crop farmer that's decided to diversify your crops, and maybe you've gone into adding some uh, cannabis or hemp or something into your program, and you may have a long history and knowledge about spray and spray equipment. But there probably are maybe some new growers into the market that might not have that same level of experience. So my main goal in this presentation is to try to bring everybody up to the kind of the same level of understanding, and through that, uh, I think that we'll all benefit from that, even if it's just an overview and a reminder of what we should do and why and what technologies are available to us. So the first question that I always like to present to people is, should we spray and why? And this leads us obviously to a concept called integrated pest management, that if you have taken your tests for private or commercial pesticide application, that concept is drilled into the subject matter pretty heavy. And really, it's coming down to, are we utilizing all of the ways to avoid pests as much as possible prior to actually determining that we're going to have to actually do a spray application. So it might be cultural things like crop rotations, uh, area and type of soil and ground that we do the planting of this high value crop. And these are all questions that we have to answer before we select a product that we have to spray. And the other thing is, you know, high value crops, if we're going to, let's compare maybe hemp to a row crop like corn, there is a lot of knowledge out there to help people prevent pests either through genetic uh, improvements or specific pesticides that handle a specific product. There's a lot of this knowledge out there for a common crop like corn, but there may not be a lot of knowledge out there for a high value crop that you've selected. And so scouting is going to have to be a big part of your daily routine and helping you to identify what types of things you're going to have to control. So these are all just concepts that I want people to make sure that they're aware of when we go into the business of doing spray applications. Now, this is an overview of what we're going to discuss in this next part of the presentation. First of all, we're going to review different sprayer types. Um, there is not one sprayer that can solve all spray application type challenges. So we're going to look at some different sprayer types, and we're going to talk about the pros and cons of those sprayer types and what ones then you can decide might be best for the crop that you're trying to grow. We're going to go through and we're going to go discuss in detail different sprayer components, and more of this is just so that we can identify common problems, common maintenance issues, things that you're going to expect when you're dealing with any kind of sprayer out there, just to help us share that experience of knowledge and help prevent issues when we go into our spray applications. Don't get frightened by the word calibration. This is going to be easy for you, but we're going to talk about calibration because it's different for a lot of high value crops that have a lot of different geometric profiles. And we're going to talk about nozzles, and we're going to do this in a way that hopefully makes a lot of sense to you, and try to eliminate and remove the typical confusion that people get when they try to approach that subject. And then toward the end of the presentation, I'm just going to highlight some safety do's and don'ts, and we'll go from there. So starting out, most people get their first spray experience using manual spray equipment. I think everybody maybe started their career in spray applications with a pump-up sprayer or maybe a backpack sprayer like one of these. There's some definite pros to these types of sprayers. They're very common. They can apply product to small areas, and the cost for the equipment is fairly low. But some of the drawbacks are that, this is a very labor-intensive way to do spray applications. And a common mistake that's made is that, someone will go into a spray job with a piece of equipment like this, and the job is just bigger than what this equipment can handle. And when a job is labor-intensive, human nature is to avoid it, or at least procrastinate on it. So it's very easy for that to lead to a missed timing of application because you just didn't want to go out and do it with inadequate equipment. Over application and under application is very common, especially with pump up type sprayers. When you first pump it up, it's going to apply quite a bit of product. And then as you continue to spray, it's going to deliver less product. So it's very easy to make errors in that regard. Mixing in small batches, if you're mixing 10 small sprayer loads, your opportunity of mixing errors increases by tenfold. So that's something to consider as well. And open field applications like the two pictures on the bottom, this would be done more effectively and more efficient with a larger type of sprayer. And then obviously there's worker protection issues too, PPE that we don't see in some of these spray applications just because people think that it's not going to be a problem for them. So, pump up sprayers, they have their place, but it's very easy to get into a situation where they're not effective for us or efficient for us. So as we start to plan our crop, we have to think about, are we going to apply some sort of pre-emergent or a burn down application to prepare the area for the application? And if you're going to do that through a herbicide or something like that, typically some sort of sprayer like this is going to be used where you're spraying the product right down to the ground and getting it where it needs to be. So that's one type of sprayer that we have to think about if we're in the planning process of putting in a crop. And once a plant is established, we may need to control competitive weeds at the base of the plants. Competitive weeds rob fertilizers, they rob nutrients from our target crop. And so we have to find a way of controlling that. Now, in an IPM or an integrated pest management program, we might consider doing cultivation. But if we run the risks of damaging the root structure of our valued crop, we may instead have to go into a spray situation. And a covered boom like this can maintain a weedless boundary, but it will control that spray so that it does not go outside of the target area and create a bigger problem. So specific sprayers like this can be helpful in some of these crop types. A lot of spraying technology migrated to the United States from Europe, and one of the first pieces of equipment that we saw out there for a lot of high value crop was air blast sprayers. And now an air blast sprayer, I'll just advance a slide. So behind the tractor, there's a machine like this. It's connected, get my pointer here. Maybe connected to the tractor here with a PTO shaft that runs through the whole device into a gearbox. It's running a large fan. This fan is drawing in air and blowing air out past these nozzles and up into the crop or out sideways into the crop. So that's what an air blast sprayer is. But one of the things that we have to be concerned about here is that we see a lot of droplets here, and typically the size of droplets that these machines develop are fairly small. And I'm going to use the word micron, where it's a unit of measure for droplet sizes, and droplets that are less than 300 micron are going to be these lighter droplets that we're going to see that really can travel a long way. Now, we might get some very good coverage, especially in this zone here, but droplets do have some mass, and even when you try to blow them straight up, there's going to be a maximum height level that those droplets are actually going to be able to reach. And so that's something to consider. These are still commonly used pieces of equipment, and we sell them at our company. But we also sell some other types of equipment that may have some better droplet size profiles. So we're going to keep talking about those here. Here's an alternative to an air blast sprayer. It's using vertical type booms, and these vertical booms are directing spray directly into the crop. And depending on how high the crop is, there's different spray tips that are used to do that. But one of the things that makes this possible is what we call twin fan nozzles. And twin fan nozzles will spray forward and back at the same time, basically creating a different geometric approach or angle of attack into the canopy or the foliage of our target crop, which improves penetration, getting droplets into the thicker parts of the plant, because it's not just trying to spray straight into it like a single fan would. It's actually using those diverging angles to approach and penetrate the canopy. I've got a video here that I'm going to play, and I'm going to play it through the Zoom tool, but it's also going to be showing up in the chat box on Zoom, so that you may want to just click on that link in the chat box and watch it through your own web tool, then you won't have any interruptions or buffering issues. So if you're watching this on my screen or shared screen and it's not showing well, just go ahead, open your chat box and click on the link that Heather is going to put in that chat box. So this is just a medley of some sprayers, and one of them is highlighting these twin fan nozzles. There you should be able to see the forward and back angle of attack. And these nozzles can be used at different pressures. This pressure is fairly low that you're seeing right now. This is probably only about 40 psi. Some different variations of vertical booms. So this application is at a higher pressure, so this is probably around 80 to 90 psi, and you'll see that the droplet size is slightly smaller, but you'll see the penetration into those hop bines. And then this is just another type of high pressure applicator, not using air blast, but just using Venturi effect. And you'll see there are some smaller droplets there. And you'll even see small enough droplets there where there's some drift. Just an example of that covered boom. Okay, I'll just wait a second here in case some folks were watching that on their own web browsers. But this is just another type of sprayer that we can use to apply to a variety of different types of crops. Another technology that's available out there is, in addition to vertical type of applicator, is electrostatic technology. Now, basically what's happening with an electrostatic sprayer is that there's an electric charge being applied to the spray nozzles, and that charge is opposite of the charge of most of what's on the plant. So most of the ions that are on the surface of plants and trees and things are a negative ion because we're connected to the ground. And you'll see that there's a chain on the back of this machine touching the ground. That's completing the circuit between the droplets and then the negative ions that are on the tree and on the ground. So what happens is that these droplets, actually, if they are smaller than that 300 micron level, usually even as small as around 100 micron, their mass is light enough that once they're charged, they will actually wrap around and penetrate into a plant. They'll actually change direction and follow the charge attraction, just like north and south on a magnet. And that really enhances the coverage of these droplets over a high value crop. There are some drawbacks. I mean, the ground is also negatively charged, so a lot of droplets are going to drop right to the ground because that's an attraction point. So we have to accept a certain level of product loss, and we also have to make sure that the product that we are applying is not going to overly contaminate the ground. But this is a technology that works very well. We've made a number of sprayers with this technology in a lot of different situations, and it can be very successful. A more typical type of sprayer for a crop that's going to be spread out over a larger area is going to be what we call ground rigs, and typically these sprayers are directing spray from the top down. You know, one of the benefits of using a sprayer like this is that this is the type of sprayer that we very frequently will fit with GPS guidance control. And once we're able to add a GPS guidance control and a flow control system on a sprayer like this, it opens up a world of possibilities. And I'll talk about that in a second here about variable rate application and prescription naps. And but this is the type of spray rig that offers a good platform to get into uh, variable rate applications and GPS guidance. One of the drawbacks of a sprayer like this, though, is that yes, you are only getting the penetration on the top of the plant. If we're trying to control powdery mildew or something that's down at the base of the plant, it's going to be a little bit more difficult to penetrate and get that application done effectively. For those of you that are under glass, there are a lot of different options in that platform as well. We build a lot of specialized spray equipment for nursery and greenhouse applications. And, you know, it really is, it comes down to almost a custom type of situation. But what we do is we really look at a number of things. We look at the, you know, the type of plant that you're trying to grow. We look at the, you know, the physical structure of that plant, how it's organized in your greenhouse area. You know, what type of alleyways do we have? Is it automated like this, where we have an overhead crane? You know, there's a lot of things like that that we consider when we are looking at specialized greenhouse type of equipment. And now more recently, we're able to do drone applications. And when I say we, I don't mean everybody, because it's not something that everyone can do because of the licensing that's required to get this done. So there are a number of FAA licenses that are required. Each operator needs to have their own UAS pilot's license. And then the company overall that's doing the application needs to have a lead pilot that has a FAA certification. It's called a 137 certification and license. And a number of exemptions have to be applied for as well to allow this. It also requires extra state licensing from whatever state you're from. You know, I've just been doing my tests in Minnesota and Wisconsin, and it's just an added category to the main categories of herbicide or pesticide applicators licenses. So that's what I mean by we. But I'm going to show this video as well, and again, Heather is going to have a video link put up in the chat box so you can watch it on your own browser if it's not buffering on my computer or showing through Zoom very well. But I'm just going to set up this application a little bit for you so you kind of understand what's going on. This is a cannabis crop that was in North Carolina, and it had been raining just constantly for about a 2-week period of time. And so it was so muddy, there was no possible way of getting a ground rig into this field. And there was a caterpillar worm identified in the crop that was going to be basically decimating the crop. And the insecticide to kill this particular pest was a very restrictive pesticide or insecticide, and the PPE was for any workers to go in and do this was was prohibitive, and this was a better alternative. And so let's go ahead and watch this video, and then I'll address a few things afterwards as well. So you can see from the ground that's quite muddy, just impossible to get any kind of ground equipment into this field. The first thing that you'll notice is that the prop wash off the props is actually moving the plants around, which is a benefit for that penetration, you know, compared to that other top-down sprayer. And if people want to watch it again, go ahead. Obviously, the links will still be up in the chat box, so people can follow up later and click on those. But really, this drone application saved this crop. There was really no other alternative. And the company that did this application is a company that Rost is working with for our licensure, called Rantizo. Rantizo is in Iowa City, Iowa. And so they hold the FAA 137 license and certificate. And then Frost has licensed drone pilots that do these applications. And people will ask, well, you know, how much does something like this cost? Well, typically there's a 2-hour minimum and there's an hourly fee, not including the chemistry. But this application was done for, you know, right around $500, and it saved the crop. So drone applications are here. It's not the future. It is here. There aren't a whole lot of companies doing it, but there are some, like Frost and Rantizo, and it can be a good tool to have in your toolbox for pest control. I'm going to introduce you to a concept called variable rate applications. And like I said at the beginning of the presentation, if you were a row crop farmer and just decided to grow something like cannabis or hemp, you would have already been very aware of what variable rate applications are, because row crop has been using this technology pretty strongly for the last couple of years. And really, it's basically a process where we collect data, and by data, I have two categories that I categorize data in. One is ground level data, and that would be data like soil nutrient information, soil moisture information, maybe even soil compaction information. For instance, you know, these field edges here were probably areas where trucks during harvest were entering the field, and you know, that red area indicated by this map is probably where there was a fair amount of compaction. So there's ground level data, but then there's also high level data. And by high level, I mean imagery like this that is taken either from a drone or a satellite or an airplane, or even a ground-driven rig can have cameras on it to pick up some of this. And we're looking at a spectrum of color that's what we call NDVI or NDRE. It's basically the amount of chlorophyll that's being bounced back to a camera. So anything that's darker green is going to be a healthier crop, and as the shades start to diminish down towards the orange and reds, indicates a less healthy part of the crop. And we can see a lot of variations in the field. And in row crop, it's very easy then for us to go on to the next step, where we take our data and we put them into a GIS program, and we make agronomic decisions and create a prescription map. So an agronomic decision in this area, now, if this was a fertilization issue, we would maybe change our rates of fertilizer when we go out and do an application. Or if it's indication of soil moisture issue, we might consider some wetting agents or something to amend the soils. But basically, once we have this information, we're able to make some agronomic decisions to see if we can vary the rate of an input instead of just spraying this whole field with one product at one rate. And the results are that we can actually save some money and still have a productive crop. Now, the last part of this process is executing whatever application that we need to get done. Now, I mentioned before with the top-down ground rigs that we can add GPS and individual nozzle control with rate control, and we can actually basically create or load the prescription map from our decision-making process directly into the monitor of that machine, go drive over that crop, and the machine will execute whatever prescription of application that we've chosen. And similarly with drones, we can segment areas of the field and say, okay, for instance, if I'm going to do an insecticide in this field, and I know that the insect infestation is stronger around the edges of my crop, well, I'm going to create one rate for around the edge of my crop and a different rate for the center of the crop. All I have to do then is send the drones out in their own separate missions. So this drone running the perimeter of the crop may run a rate of 8 gallons per acre. But in the middle part of the crop, I might have a zone that's maybe only 4 gallons per acre. So that's how through drones we can execute variable rate types of maps. I'm going to look forward to Terry from Centera and his presentation coming up, because he's going to go into a lot more detail on this. But I just want to kind of get people warmed up to the concept and have you understand this and be waiting for that presentation coming up. We're going to shift gears now, and I'm going to kind of go into just some basic sprayer components and some of the things that we need to look out for on sprayer components. And first off, we're going to talk about the tank. And the first thing we want to make sure is that a tank, whatever the tank capacity is, it needs to fit and be adequate for whatever vehicle that tank is on. So we don't want to have a tank that's too big for the small chassis of a sprayer or small vehicle. And tanks are typically made out of a variety of materials, stainless steel, fiberglass, and very commonly polyethylene. One thing to consider here is if you're a do-it-yourselfer and you're going to try to put a sprayer together and you've got an old tank that's been sitting behind a building, older generations of poly tanks did not have UV inhibitors in the plastic. And so it's very common to see stress fractures around the top of the tank where it's been exposed to sun. Don't use those tanks. Just get a new tank. You're just going to be expecting a catastrophe down the road if you're using a tank that's compromised. So the next thing that we need to make sure that we do is on any tank that there is, for any penetration into the tank, that we have a shutoff valve. And this is, for obvious reasons, if there is a problem with the rest of the spray system, we need to be able to shut off the supply from the tank to the rest of the system so that we can do whatever service or maintenance needs to be done. So make sure there are shut-off valves on any of these penetrations. Next, it's important to make sure that the sprayer that you have, or the tank that you have on your sprayer, has a sump. And we see a lot of sprayers in fleet stores and things of that nature, or places like that, that don't have a sump in the bottom. And they're very frustrating because you get down to the end of your material and it's no longer being picked up by the pump, and you're left with 2 or 3 gallons of product sloshing around in the back of the tank. So a sump will help prevent that. It'll also help you in your rinsing and cleaning process to get all of your rinsate out so that when you move on to your next application, that tank is clean and ready for use. The next thing that we need to make sure that we have is an air gap fitting on the top of the tank. And specifically what that looks like is this device right here, where basically it's a bracket holding a fitting that a hose can connect to that elevates the nozzle above the top level of the tank. And you might think, well, okay, I always thought that that was just for holding the hose. And that is a side benefit. But the real reason why we use these is for this little guy right here. This is a frost-free water hydrant. So basically, there is a plunger and a rod going down this pipe, down to a valve at the bottom. When you raise the handle, it lifts up the plunger and water goes up and out. However, when you close the handle, all the water that's in the tube drains out a little hole on the side down underneath the frost line. So the reason why we have an air gap is if we were filling our spray tank and we put our chemistry in and we decided, oh, wait, it's too close to lunch, I'm going to go have lunch. I'm going to shut off the water, I'm going to shut this handle, and I'm going to go eat my sandwich and come back and do my spray application. Well, in that period of time, if this hose was in the tank, siphon effect would draw liquid from the tank of the sprayer down and basically inject that product into your ground below the frost line, or just the ground period. And that is definitely a contamination issue, and that's why we need to avoid this. And it's just best to have an air gap fitting on the top of your tank. Now, different states have different rules. You can use some check valves, but I know, for instance, in Minnesota, that a check valve on a hydrant has to be installed by a licensed plumber, and it has to be inspected, and there has to be a tag on it, a minimum of every other year. So sometimes that's preventative, and an air gap fitting is a more economical way of doing that. The next is agitation or jet agitation. A lot of products used in high value crops might be solution or non-soluble. They might be wettable powders. They might be emulsified products. And if they aren't continuously mixed, they will start to separate in the tank. Even if you're traveling across a bumpy field, you won't have the mixing, and you go out and you start your application and you get very good coverage maybe on the first part of your crop, but the second part of your crop, we maybe didn't get any coverage or efficacy because our product separated and started to stratify in the tank. So a jet agitator will constantly recirculate this product and make sure that it's uniform for application. Next in line is a pump. Pumps can be, there a variety of pumps. Centrifugal pumps generally deliver a lower pressure. If you want a higher pressure for better foliage penetration, typically we'll look at diaphragm pumps or roller pumps as well. Diaphragm pumps last much longer than roller pumps. Roller pumps are cheap, but one of the biggest problems with roller pumps is that they don't have a lot of flow. And a roller pump, what I'm talking about, is a pump that connects directly to a PTO shaft on a tractor. And for instance, most roller pumps will, when they're brand new, will deliver maybe 10 gallons per acre or 10 gallons per minute. And that might be close to what all of your nozzles is requiring. And it might have some volume for some recirculation or some jet agitation. But for instance, a cast iron roller pump from a fleet store is going to wear pretty quickly, and you may only have 6 gallons per minute available. And then all of a sudden your spray is going to drop off and you're not going to have any agitation. So investing in the right pump that's going to serve you for a long period of time is important. Centrifugal pumps utilize a vent line. That's just all we're showing there. Filters. This is one of the areas where a lot of mistakes are made. It's very common for people to call and tell us that, the pattern coming out of my nozzles is very weak. I'm not able to build pressure. So I train all my staff to ask the question first, well, did you check your filter? Because 9 times out of 10, that filter's plugged up and it's not delivering the adequate flow out the nozzles. So checking the filter frequently, especially if you're using a product that you haven't used in the past or your water source might be variable, make sure that you check your filters. The other error that can be made is that you choose a filter screen that's too large for the nozzles that you have chosen. In that case, we have to, well, you're going to plug your nozzles. That's going to be the first problem. And so we have to change that filter screen to a more suitable filter size. Pressure control valves. I'm going to move forward through some of these a little bit more quickly here. Boom sections, obviously we're controlling different sections of the boom. A flow meter, if we have an automated system, is important. We need to calibrate that. And then spray nozzles. Spray nozzles are the most important component on our sprayer because it's the last piece that is responsible for delivering the spray to our target plant. So I'm going to go into calibration methods and nozzles. Quick run through on a textbook example. We're going to talk about pre-calibrated nozzles and just a practical calibration test. So our textbook example of calibration is we just basically want to find out how many gallons per acre our sprayer puts out on total volume, and then we can add our product or our chemistry to that volume at whatever rate the label asks us to do. So gallons per acre, there's this formula that we use as a guide. So say for instance, I've got a new sprayer from Rost. I have no idea what it puts out. So I'm going to set the pump and set the pressure, and I'm going to collect liquid from all the nozzles for a minute to get this GPM number. So say I collected 6 gallons and I know that I want to travel at 3 miles an hour, and my width of my spray boom is 10 feet, so it's 120 inches. I know that this machine is putting out roughly 100 gallons per acre. Make note that if you change the pressure, it will change that rate. And you typically would want to repeat this a number of times to minimize mathematical errors. But pre-calibrated nozzles offer us another tool for easier calibration. Basically, ISO, the International Standards Organization, has standardized the nozzles based on their orifice size and color-coded them. And it doesn't matter whose company you're buying the nozzles from, these ISO color codes are universal. And it tells us how many gallons per minute that nozzle will put out at a given PSI, in this case, 40 PSI. So if we're going to do a calibration, a catch test with a calibrated nozzle, we can set our spray pressure at the nozzle at 40 PSI. We can collect, I'm a little bit short attention span, so I only collect for 30 seconds. So if there's 128 ounces in a gallon, and we've got the white nozzle on here, so we know at 40 PSI it should deliver 0.8 gallons per minute. We multiply that by 128 and divide it by 2 because I'm only collecting for 30 seconds. That tells us that I should be collecting 51.2 ounces for that nozzle. If I collect less than that, it might mean that that nozzle is plugged. If I collect more than that, it probably means that the nozzle is worn out and should be replaced. And what we want to do in this case is collect from each nozzle to compare the wear across the boom. If that wear is more than 7%, then the nozzles should be replaced. So when choosing these nozzles, one thing I want people to be aware of is that there are different wear rates. Brass nozzles were the first nozzles that were used because brass was easy to machine, but it also wears very quickly. There's a conception out there that stainless steel wears much longer than anything, and that's actually not true. Ceramic is the best material, and polyacetal is what most spray tips are made of today. Actually wears pretty well, and the economic value is very, very good. So the traditional way of choosing nozzles would be that we would find a chart like this. And one of the problems that we have is nozzle spacing. All of these charts were basically made for row crop, and very few of them were made for anything special as far as specialized crops. So we would have to choose spacing, we'd choose a speed range, and even speed ranges may not be on these charts. And we'd have to extrapolate, if I wanted to apply 15 gallons per acre, I'd have to find these numbers down here, then come over here and figure out what pressure I should be spraying, and then lastly, see if maybe I'm going to be using the right droplet size. So these charts are actually kind of a problem. And especially when we're talking about specialized crops, nozzle spacing, that's the big question. So in specialized crops, we define nozzle spacing by the width of the row divided by the number of nozzles. So if we have a 10-foot row between hop rows, for instance, these are hop plants, and if I'm going to spray the whole thing, I might be using 5 nozzles on either side. So that's a total of 10 nozzles. So in this case, that means that our nozzle spacing is 12 inches. And this is because EPA doesn't regulate products based on how high they are and how many number of nozzles. They do everything based on GPA, or gallons per acre, or gallons over ground spatial area. So for instance, if we were only going to be spraying the lower portion of a plant and we're only doing four nozzles, we would do 120 inches divided by 4. So our nozzle spacing then would be 30 inches. So keep that in mind. That helps us when we come to a tool like this. And a tool like this is a better way for us to choose spray nozzles. First of all, it's available as an app or as a web tool. This happens to be one from Hypro or Pentair. We can put in a specific nozzle spacing, which is very helpful for our high value crops. We can put in whatever speed we want to go. We can put in whatever rate we want to apply. And we can even indicate droplet size. Now the question is, where do we get the droplet size information? Well, we get it from the label. And in the precautions or the use area of a label, it's going to identify droplet size. In this case, it's saying medium or coarser droplet for this product. So that's where we get that information, and we can enter that here. In this app, I like to just leave that unfilled and then press submit. And it'll put out some information like this. First of all, it'll tell us exactly what pressure each nozzle should be sprayed with. Again, these are ISO color-coded nozzles, so they're pre-calibrated. And if you notice, the gallons per minute is the same for each of them. And that can be used as a tool for calibration as well. But also, it's going to tell us what droplet size we're going to see with that nozzle at that pressure range. And in this case, we see a medium droplet. And that's good because that's what's on our chemistry label. There are technologies out there called air induction that create larger droplets. And it also is showing us some options here. Again, the pressures are the same as the non-air inducted nozzles in this case, and we see that the gallons per minute are the same. But in this case, we see, okay, this 025 nozzle has got a medium droplet, which is still good with our chemical label. And this droplet at 59 psi, or this nozzle at 59 psi, is developing coarse droplets. It's also on our label because it's under coarser, and we may choose that because it may minimize some of those drift potential droplets. So that's just a way for us to choose nozzles. And lastly, as far as a calibration, a practical test is really kind of what we do every time we do an application. But if you want, you can do it first with just water. We have a defined area. So if we know we have 1 acre that we're going to cover, then we define the nozzles. We set a constant speed. We set a constant pressure. And we go through that field and record the volume. So if we expected to apply 100 gallons per acre and we come back and we have 50 gallons left in the tank, then we know that we're off somehow. Either we have to change our pressure or we have to change our speed, whatever, because we under applied by 50 gallons. And the same as if we got halfway through that 1 acre and we were out of our 100 gallons, then we know that we've over applied. So every time we do an application, we kind of do this practical test, or we should be doing it, just to make sure that we're actually applying the volume that we intend to. I'm going to just probably do a couple more slides, and then I'm going to stop the presentation. I want you to be aware of the concept of application verification. In addition to verifying and making sure that our spray volumes are coming out correctly, we want to actually look at the plant and make sure that droplets are getting where they need to be. A great tool for finding this out is using water-sensitive papers. Basically, when water droplets hit this film, it turns into a blue dot. And there's a couple things that we can identify from those dots. First of all, we can see the presence of coverage. And second of all, the larger the drop, we know the larger the droplet size. But we can place these water-sensitive papers using just like a clothesline clip or a paper clip on leaves, maybe close in through the foliage or under the canopy, and verify that our spray is actually getting there. Because if we don't get the efficacy that we don't want to blame the chemistry if we didn't actually get good coverage on the plant. The other thing that these water-sensitive papers can do for us is they can help indicate or protect our high-value crops from neighboring spray applications. So if you put a water-sensitive paper on a post and someone, your neighbor is maybe spraying his soybeans, but you want to make sure that none of his spray gets onto your ornamentals, you can put the water-sensitive papers around the perimeter and just verify that none of those droplets are getting into your ornamentals. So those are some tools and some tips and things that I strongly recommend people use and pay attention to. And, hopefully these are things that can help you in your spray applications. The rest of my slides really kind of had some
can you have a few questions
and some do's and don'ts. But I think I'm going to stop the presentation here, allow for any questions that folks might have. And I really appreciate the time today. And hopefully you guys are successful in your growing, and we can help you out any way possible.
Yeah, thank you, Ken. We had a couple questions, and I wasn't on the whole time. I had to jump off real quickly, but so maybe you answered this already. But where should the filter be installed, before or after the pump?
On a centrifugal pump, the filter should be after the pump because a centrifugal pump can handle larger debris and contaminants. And centrifugal pumps push better than they pull. A positive displacement pump like a roller pump or a diaphragm pump, you want to have the filter before the pump to help protect the pump from any of those debris or particulates that could wear that pump down faster.
Gotcha. And another one, would the electrostatic sprayer work well in a greenhouse setting?
They do work in a greenhouse setting. However, there are more negatively charged structures in a greenhouse. Obviously, all of your galvanized and metal pillars, all of that is grounded. And so you are going to attract those droplets to that those structures. If there's enough separation, there usually has to be a couple feet of separation from any of those metal structures in order for the electrostatic droplets to decide to go towards your target crop versus onto the structure inside the building.
Wonderful. Yeah, this was a great presentation, Ken. Thank you very much. The calibration is always important to remember. And then the water sensitive papers here at the end, that was really insightful stuff, and also very important to understand drift and deposition. So thank you very much for your time, Ken. If anybody else has questions, I'll be sure to get those over to you after the presentation. And if you hang out for just a few more minutes or whatever, people can probably use the Q&A function to get in touch with you on there as well.
Awesome. Thank you.
Did you list how people can get in touch with you? Do you have a slide for that? You're on mute, Ken, if you're chatting.
Sure. Let me get to the complete end here. And there's my email address, folks. If you have questions, go ahead and still put them into the chat. I think everyone benefits if you put questions into the chat because it's all then knowledge that we can share. But if you have something commercially specific or non-commercially, you can contact me through this email address that's on the screen. And I look forward to helping anybody. I enjoy this industry and I enjoy the folks at Winfield. So again, thanks a lot for having us.
We